Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to learn about solving exponential and logarithmic equations. So let's go ahead and get started. Now, before we get into the details of this, I have to teach you one more property of logarithms, and that is called the one-to-one property. So to make it as simple as possible, and this is kind of something we've been talking about intuitively, maybe not directly, when you have log base a with the argument of m and it equals log base a the argument of n, well then you can safely conclude that m equals n. That's kind of how it works out. So this should not be surprising. You can see here clearly that we have the same base, and the only thing that's different is the argument, but we are claiming that they equal each other. So in other words, I can remove the log, and then you can see right here that m must equal n because that's all that's left. And this is the same idea that we talk about when we're dealing with exponents. So this is not an unusual conclusion that we're making here. So keep this in mind as we go through the examples in this video, because that's what we're going to do right now. So for our first example, as we were trying to do with solving exponential and logarithmic equations, let's say we have the following. Imagine I have 2 times the log base 3 with the argument of x equals log base 3 with the argument of 36. Now, the first thing I have to do here is I need to do the power property. That's what I need to do. I need to, in other words, to make this as clear as possible, I need to move this coefficient or this constant 2, and I need to move him right here. And so to do that, I just do the following. So now I have log base 3 with the argument of x squared equals, log base 3 with the argument of 36. Now I can use the one-to-one property because remember, you can clearly see that I have the same log base 3 on both sides, so I don't have to deal with that because they both affect the answer the same way. So I can remove that to make life simple, and I'm left with x squared equals 36. Well, if I square root both sides of this, which I'm sure you've seen this before, I can say x equals 6, and I'm done. That's all you have to do there in that particular example. And so by being familiar with the different properties of logarithms, and then understanding the one-to-one property as well, you're able to quickly and efficiently solve this particular logarithmic equation. Let's do another one. So this time, I have log base 2 multiplied by the argument of x plus log base 2 times the quantity of x minus 2, and all this equals 3. All right, now the first thing we're going to do here is we're going to use the product property. So in other words, if these two logarithms are added together like this and they have the same base as such, I can rewrite that as follows. And again, this is a review of what we've talked about in prior videos. I can say log base 2 times x minus 2 equals 3. That's what I can do, like so. Not that complicated. Now, what I can do next is I can write things in what we call an exponential form. In other words, what I'm going to do here is I'm going to remove the logarithm by writing an exponential form. And again, this is something we've talked about in prior videos, so we can't review it again, but here's what it will look like. This 2 right here, he's going to go over here, and he's going to be the base. And then the 3 right here, he's going to become the new exponent. Trust me, this will make more sense when you see it. And then the x times the quantity of x minus 2 is going to pretty much stay the same. So here's what we got now. We're going to have 2 to the third power, because I'm taking this guy, making him the base here, and I'm taking this 3, making him the exponent, equals x times the quantity of x minus 2. And so now we can simplify this. You can see basic algebra. We got 8, because 2 to the third power is 8. And then we got x squared minus 2x. I just distributed the x, not that complicated. Now, what do we do next? Well, I subtract 8 from both sides. And it was 0 equals x squared minus 2x minus 8. And then this is just basic algebra by this point. And so if I factor this out, which again, I'm going to save you the dance of doing that, but essentially I'm looking for something when I multiply it, it'll give me 8, and when I add it together, I'll get negative 2. And so for me, I can tell just from looking at this, x minus 4, and then x plus 2, because negative 4 plus 2 is going to be my negative 2, and negative 4 times positive 2 will give me my negative 8, like so. So that means x can equal either 4 or negative 2. However, there's a caveat that logarithms cannot deal with negative numbers because we're not messing with imaginary numbers in this particular example. So our answer can only be x equals 4. And you can check that on your own time. But you can see the process here of being familiar with how to go between exponential form and logarithmic form, understanding the properties of logarithms, and using all these different tools to address different problems. Let's do one more. This one's kind of tough. Okay, so in this example, we're going to be doing the following. We're doing, let's see here, log of x plus 2, so obviously our base is 10 because we didn't write anything, minus log of 4x plus 3 equals negative log x. Now this one's tricky. Now the first thing we're going to do is we're going to use the quotient property right here to deal with this. Quotient property, we talked about it in a prior video, and so here's what we got. We get log multiplied by the quantity of x plus 2 over 4x plus 3. That's what we get, and then we get equals log of x to the minus 1. So I forgot to mention that we rewrote this. So negative log x can also be written as x to the minus 1. That's something I forgot to mention. Forgive me for that. Oh yeah, that's right. This should be negative 1 up here, huh? Okay, this should be negative 1 up here, I believe. Not minus. Made a mistake right there. That's okay. All right, so we're going to rewrite this again. Now we're going to deal with this guy right here. He should be a negative 1. As an exponent, so we're going to rewrite that as a fraction. So this is going to be log x plus 2 over 4x plus 3 equals log 1 over x. That's what we got there. Now here's the thing. We have the same pattern of log base 10 on both sides, so we can use the one-to-one property. And so that means we're going to have the following. X plus 2 over 4x plus 3 equals 1 over x. Let me go back because I wasn't quite clear. Up here I made a mistake. I put negative log x. I should have put x to the negative 1 here. So log x to the negative 1. And so when you rewrite that as a fraction, you get 1 over x. So that's a mistake I made there. But we're wrapping this up. And so now it's just a matter of just solving for x. So you just cross multiply. This is one way to deal with it. So to cross multiply, I simply do the following. I multiply these guys together and I multiply these guys together. So I get 4x plus 3 equals, then I have, let's see here, x times the quantity of x plus 2. That's how that works out. And so this comes out to be x squared plus 2x equals 4x plus 3. You can see this is not that deep. I subtract 4x from both sides. I subtract 4x from both sides. I subtract 3 from both sides. And so I end up with 0 on the left equals x squared minus 2x minus 3. So essentially I'm looking for a number here when I want to deal with this quadratic here, where when I multiply it I get negative 3, and when I add it together I get negative 2. And so again, just using my experience here, I can tell you right now that it's going to be x minus 3 and then x plus 1, because negative 3 plus 1 is going to give me my negative 2, and negative 3 times 1 is going to give me my negative 3. Therefore, we can conclude that x can equal 3 or negative 1. However, like I told you in the previous example, we're not dealing with imaginary numbers here with these logarithms, so x can only equal 3. And so therefore you have it. So many steps, but we've got it done. So let me go back and explain what happened in this video, and then we will wrap it up and conclude it. So in this video, we talked about how, examples of solving exponential and logarithmic equations. And so we began with the one-to-one principle, one-to-one property. where you have when you have the same log and the same base, whatever that means that the it equals whatever, that means that the arguments are going to have the same value. And so in our first example here, you can see what we did. We first used the power rule to get our x squared here, and then since we already have the same logarithm with the same base here, we were able to ignore that and get x squared equals 36. We square rooted it, and we got our final answer like so. And this next example was a little bit more complicated. We had to do some more steps, but it was just more of the same essentially. We start with using the product property here at the top, right here at the top, then the exponential property over here, and then we solved it accordingly once we got into a quadratic. And then in this last example, again, we started with the quotient property, and then we rewrote the negative exponent as as a fraction, 1 over x, and then we're able to wrap it up by using the one-to-one property, get the quadratic, solve for 0, and then finish it. So again, what you really do with these exponentials and logarithms really depends on the situation and how you want to address these things. However, by being aware of the different tools that are available, you are able to have success when you have to try to solve these. So, my name is Derek Thomas. I am the Director of Educational Research Techniques. Take care.